We're going to do some practice for the DMA for Unit 8 on Performance Matters, and it's about integers. I know you guys are probably getting really tired of these DMAs, and trust me, I get it. And if you're wondering, like we did Unit 5, and then now we're on Unit 8, why we skipped over some units, it's because Units 6 and 7 didn't have any DMAs that the district made for us to have to take. So I guess that is the good news. All right, so these problems aren't too bad. They're all about integers, which are those positive and negative numbers, okay? So on this first question, again, this question on this study guide is really similar to question number 1 on Performance Matters. So it's your choice when you're watching this video. You can watch me do this question number 1 and then pause the video and then go over to Performance Matters and do question number 1 on Performance Matters, which again is really similar to this question, but the numbers are different. Okay, obviously I can't give you the exact question. Or if you prefer, go through and work out these problems, all of the problems with me on the study guide, and then go and do the DMA completely on your own. Your choice. You can use calculators though, so just keep that in mind. So for question number 1, it says, on Tuesday, the temperature at 9 a.m. was -4 degrees Fahrenheit. The temperature at 4 p.m. was 7 degrees Fahrenheit. From 9 a.m. to 4 p.m., the temperature blank degrees. All right, so first of all, if it's -4 and then it went to being 7 degrees, obviously it got warmer. So when we look over here at our answer choices, the temperature obviously increased. So that is going to eliminate 2 of my answer choices automatically without me doing any math whatsoever. So then when I think about how many degrees did it increase, well, if you're at -4 and then you get to 0, that is going up 4 degrees. And then if you're going from 0 to 7, that's up another 7 degrees. So that would be a total of 11 degrees increased. So your choice is B. Again, if you want to pause the video, you can go over and do question number 1 on Performance Matters, and then come back to this video when you're ready for question 2. For question number 2, it says, Bill charges $9.25 per hour for washing cars. If he works 6 1/4 hours a day, about how much money will Bill make in a 5-day work week? Now, this word about, I believe, might be in bold print, but they don't have it capitalized and underlined on Performance Matters. But that's an important word here. This means that we want to estimate, okay? And a lot of times people, when they estimate, they have a harder time than just doing the actual problem. So this is what we're going to do. So first of all, let's make sense of the problem. He makes $9.25 per hour, and he works 6 1/4 hours a day. So if we wanted an exact number for how much he made in one day, it would be $9.25 times 6 1/4 hours. But since we are going to estimate, I'm going to estimate that this $9.25 is just $9. And I'm going to estimate that 6 1/4 hours is just 6 hours. So if I do 9 times 6, I get $54. And this is how much he makes each day. Now, he works 5 days. So if one day he makes $54 and he's working 5 days, I'm then going to do 54 times 5. And again, like I was saying, you can use a calculator for this. So this would just be 54 times 5, and we get $270. And you can see that that is one of my choices over here. So make sure on question number 2 that you do estimate like I did here. Makes it a lot easier. All right, moving on to question 3. All of this goes along with question 3, okay? This is one of them where you would drag a name and drag an answer, drag a name, drag an answer. And it doesn't matter what order you have your names on Performance Matters. So in question number 3 here on the study guide, Phil, Paul, and Pat took a test. For each correct answer, they earned 3 points. For each incorrect answer, they earned -3/4 point. The number of correct and incorrect answers for each student is shown. Phil, 14 correct, 3 incorrect. Paul, Pat. Okay, so what we want to know is their total points, and these, we have 5 answer choices. We're only going to be choosing 3 of them, okay? So first of all, let's do something to make this problem easier for us. Most people feel that working with decimals is a lot easier than working with fractions. So instead of saying -3/4, let's say a -0.75. Okay, that'll help. So for every correct answer, they earn 3 points. For every incorrect answer, they lose 0.75 points. Now let's focus on Phil first. So Phil had 14 correct. So if he had 14 correct and he's getting 3 points for each one that he gets correct, we're going to figure out what that answer is in just a second. And then we're going to subtract the points for the amount that he got incorrect. He got 3 incorrect. And for each one incorrect, it's 0.75 points. So we're going to do 3 times 0.75. So if you can see what I did here, I just put this minus sign, my negative sign here, which is going to make this amount the negative, and it'll totally work out easy for us. So we can just work it out like a normal problem. So let's do, using our calculator, 14 times 3. And we get 42 points. So that's how many points he earned. And then we're going to subtract 3 times 0.75. Again, use your calculator. And you get 2.25. And we're going to subtract those 2 numbers. And we get 39.75. Now, if you can see down here, we don't have decimal numbers down here. We hopefully all know that 0.75 means 3/4. So this is the same thing as 39 and 3/4. And there's that choice here. So this is Phil. So on Performance Matters, you would actually drag that number over next to the correct name, okay? I'm just going to write it in my box on the study guide. Next up, I'm going to do Paul, and I will change colors so it doesn't look quite as confusing. So for Paul, he had 10 correct. So again, for each one that is correct, I'm going to have 3 points. And then I'm going to subtract from that the amount of problems he got incorrect. 7 incorrect. And again, each of those incorrect problems, he loses 0.75. So 10 times 3, 30 points that he earned. And then we're going to subtract, do 7 times 0.75. I typed it in wrong. And we get 5.25, that points that he is losing. So we subtract that from 30, and we get 24.75. So again, it's going to be 24 3/4. So looking down here, there it is right here, that's Paul. All right, and lastly, we are looking at Pat. It says Pat got 16 correct and 1 incorrect. You can see how all of these problems are set up the same way. The only thing that I'm changing about these problems is the number they got right and the number they got wrong. Okay, so you're going to set up your problem on Performance Matters in a really similar way. Just be careful. Again, I changed numbers around on this study guide. So look how many points you got correct on Performance Matters. Look how many points you lose for getting incorrect on Performance Matters. All right, back to this problem. 16 times 3 is 48. 1 times 0.75 is 0.75. So that's going to give us 47.25. And if we're going to turn that into fraction form, it would be 47 1/4. 0.25 is 1/4. So looking down here, here it is right here. Pat, 47 1/4. All right, we're going to move on now to question number 4. And I kind of liked question number 4. I'm not sure if you guys have ever done this in science class or not, but there is a formula for changing if you have degrees Fahrenheit, changing it into Celsius, or if you have Celsius, to change it into Fahrenheit. So again, this is a real formula. It's not something that's just made up for this DMA. But it says the formula for converting degrees in Fahrenheit to Celsius. So this is if you have it already in degrees Fahrenheit, which is what we're used to in the United States. This is how you would write it in Fahrenheit. This is the formula right here. If the Fahrenheit temperature is 86 degrees, what is the temperature in Celsius? So we're going to replace the F, the capital F, with this 86. So I'm going to rewrite this 5 ninths, parentheses. Again, replacing the F with this 86 minus 32. Okay, this is going to give me Celsius. So my first step is going to be to subtract 86 minus 32. And you're fine. You can use your calculator if you want to, just so you don't make any mistakes. And that's going to give us 5 ninths, parentheses, 54. All right, a reminder about how to multiply a fraction times a whole number. To do this, we have to write this whole number in fraction form. So I'm going to put the 54 over 1. So again, it's going to be 5 ninths times 54 over 1. All right, the easiest thing to do, and some of you don't like to do it, but the easiest thing to do here is to cross reduce. I see that the 9 and the 54 can both be divided by 9. That would save us a lot of time. But again, I know that a lot of you don't like to do this, and we can use a calculator. So I will go ahead and carry on without doing that. But for those of you that like to cross reduce and feel okay about it, I would definitely do it on this problem. All right, so for 5 times 54, I get 270. And for 9 times 1, I get 9. And then I'm going to do 270 divided by 9. And that gives me 30. Again, that was 270 divided by 9. So looking over here, 30. So if it's 86 degrees Fahrenheit, which is a pretty warm day, it would only be 30 degrees Celsius. All right, moving on to question number 5. It says that Sam lost 45 pounds. He gained 12 pounds back and then lost an additional 18 pounds. What integer best represents Sam's change in weight? And we can see that we have either he gained 15 or lost 15, or he gained 51 or lost 51. And this is overall, okay? So again, if he lost 45. So we're going to use some key words here to know if lost 45 means negative 45 or positive 45. So lost would be a negative 45. He gained 12 pounds back. Maybe it was Thanksgiving time or something like we're all doing right now. Or maybe it was COVID, right? 2020. Gained 12, so that's plus 12. And then he lost an additional 18. So we would have figured out overall what was his change. Now, I would hope that you all can see that he has lost more weight than he's gained. So when I look over here at my answer choices, again, he has lost more weight than he's gained. So A is going to be eliminated and C is going to be eliminated. So now we're down to B or D where we have this negative amount overall. Okay, so first of all, I'm going to do this here. Now, in a calculator like this, all calculators are different the way you put stuff in, but if you have a calculator similar to this, you'll look down here next to the decimal number, you see this negative sign. And if I hit the negative sign, okay, it's different than using the minus sign over here. You want to use the negative sign that's down by your decimal. So a negative 45, there it is, plus 12 gives me a negative 33. So he lost 45 pounds, gained 12 pounds back, but he was still down 33 pounds, okay? And then he lost another 18. So if I just keep this negative 33, okay, and then I do he lost minus 18, he's lost a total of 51 pounds. Hopefully he had enough weight to lose that didn't make him sick. That's a lot of weight, right? All right, moving on to question number 6. We only have 2 more. Question 6, here we go. The change in price for a certain brand of socks from 2010 to 2012 is shown in the table. In 2009, the price of the socks was $2.85. What was the price of the socks at the end of 2012? Use only numbers and symbols in your answer. So what it's saying is that the change in the price from 2010 to 2012 is right here. Either goes up or it goes down, okay? And it's telling you in 2009, so 2009 would be kind of like the starting price. So the starting price was $2.85. And again, this is 2009. So it says in 2010, it went up. That's what that plus is for. It went up 20 cents. So I'm going to add on 20 cents. Please feel free to use a calculator here. I'm not going to, but you may. So in 2010, the price was $3.05. So we took care of that one. Then the next year, the following year, it went up 30 cents. So I'm going to add 30 cents on. And now the price of the socks in 2011 is $3.35. And then in 2012, it went down 30 cents. So I'm going to subtract that 30 cents, and we are back to $3.05 for 2012. So all it is wanting here is this. Don't include that 2012 or any words with your answers. Now, I want to point out something else. Some of you may have noticed that it went up 20 cents, it went up 30, and then went down 30. So what happens here, this plus 30 and negative 30, those are opposites from each other. So really, they kind of cancel each other out. And if we would have stopped, we would have said, all right, well, whatever the price was after 2010 is what we're going to go with. We really could have just done that one step and been finished. But I wanted to go ahead and work this out so you saw it. All right, we are on to our last question, number 7. Beginning in 1985, a glacier lost an average of 2.8 meters of thickness each year. By the way, a meter is kind of like a yardstick. So 2.8, almost 3 yardsticks every year. Find the total change in thickness by the end of 2019. Explain your process and answer. All right, so first of all, we started in 1985 and we're talking about 2019. If we're explaining our process, I would type in, the first thing that I would do is find how many years are between 1985 and 2019. So let's do that. So again, 1985 to 2019. So if you can do this in your calculator, or if you'd prefer, just work it out. 2019 minus 1985. And we get that it's 34 years, 34 years. Another way you could have done this is the way I would have done it mentally, is I would have thought 1985 to the year 2000 would be 15 years. And then 2000 to 2019 would be another 19. So 15 and 19 give me 34. Okay, so first, again, we're explaining our process. So you would type all this in, okay? First thing you need to do is figure out how many years we're looking at. So we're looking at 34 years. Next thing that we're going to do is for every year, it's 2.8 meters. So I am going to multiply 34 times 2.8. So again, get my calculator. I already have my 34 in my calculator. That makes it nice. So I'm just going to do times 2.8. And I get 95.2. So this is meters. So to answer the question, from 1985 to the year 2019, the glacier changed 95.2 meters. It lost 95.2 meters of thickness, okay? And again, you would need to type in that answer for me. Okay, that is the end of DMA for unit number 8. And this will be our last thing that we have for quarter 2. So just so you know, make sure that for quarter 2 that you've looked on PowerSchool and that you have all of your assignments, that you're caught up. And that will be the other goal that you have next week. The end of the quarter is December 4th. But that's my last day of work too. So I would really like all of your work to be in by December 3rd or December 4th morning. Like if you want to work Thursday night at midnight, that's fine. But when I am here at work on Friday, December 4th, I would like to be able to have all work submitted so I can get PowerSchool updated and make sure that quarter 1 and quarter 2 get averaged and all that stuff. So anyway, yeah, December 3rd, Thursday, December 3rd, at some point or before Friday morning, December 4th, all of your late work needs to be turned in. And this DMA for unit number 8 is your last thing that will be going in PowerSchool. Okay.